Before we get too deep into this, I wanted to let you know that I've been trying for about 2 years to set this up. So I'm very proud and very happy to present this to you. Hello friends, and welcome to what I feel is going to be such a unique opportunity. In the military, we often value our secrecy to try to mitigate some of the risk as we go about our work throughout our career. I will therefore simply introduce my guest as Chris and tell you in very vague terms that as long as I've been in the military, Chris has been in the Air Force. Chris is a helicopter pilot with operational service in the same sort of dodgy places that I've served in the Middle East and parts of Africa. He is a leader and a wealth of knowledge. He decided to share his time with us to test out some theories and give us some perspective. Chris offered to test DCS with the Motion platform to see how realistically it's able to simulate reality. This being the first video and the first checkout, we didn't get into missions or anything complex, simply flying around to make an assessment of the system. The military has this phrase, train like you fight, so we're all curious to see how our gear stacks up. There's a condensed version of my time with Chris, but this is our time with just cameras rolling. I have timestamps in the description. It's important for you to share this very unique video. Please offer your comments, feedback, or questions. Here we go. Thank you, Chris, for coming to the studio. I'd wanted to do this one for many years, like the real pilot fake helicopter thing. It's been on my bucket list for a long time. So, and what a fantastic opportunity this is for basically this. I get to talk about aircraft. I get to talk about how it relates to sim. And then we get to, test more complex missions and not necessarily put you through your paces, but I really am curious to see how simulation translates back and forth, right? Like how we all know you can die 1,000 times in simulation, die once in real, and it matters. So it's interesting to see how good the equipment is or how good the simulation can be or how well it can represent. And of course, my viewers are interested in that because they spend $10,000, $5,000 on equipment. They want to know how real they're getting or how close they're getting to that. It's just fun. Our wives worked together in the past, and you're a flight commander, and at the time offered to take my wife for a flight on one of your training flights. I hope she told you, but she really had a good time. There was like all kinds of selfies, Facebook picture, so like videos, all that other stuff. So I've always loved machines, and military has the best. Helicopter is that niche, right? All of us wannabes, that's like the holy grail because everyone knows it's the most complicated or has the most finesse, right? A little bit of finesse is required. Anyone could fly a plane in simulation, but everyone wants to know if they can fly chopper. So okay. It took me a bunch to get off. It was super frustrating. But once I started to figure out the basics of how it went, I found it very pleasurable and very fun to just fly, not even have a mission or a reason to do it. Just take off and go somewhere, fly through the trees, get really close. So, but my experience in real life has always just been as a passenger. So like Kiowa CH-136, got a chance to backseat that. That was fun, but it's basically just a Bell Jet Ranger. It's just a Civi helicopter. And then of course the Griffin. And then we, in Bosnia, over multiple times had lots of opportunity with our NATO partners. So like an Mi-8, that was bad because we had a sergeant who basically told the Czech pilot, I bet you can't make me throw up. Oh. So it was all negative G's, and like I was using the seat lap belt more than anything else on that chopper. And of course, British Gazelle, a French Puma, and got to lay next to a Lynx, one of the most acrobatic helicopters. We were doing a blue light. So I was an injured Bosnian farmer that got crashed on by the helicopter. That was the scenario. Okay. And of course the medics showed up and worked on me and everything like that. So at least I got to see a Lynx up close and personal. And then of course, Afghanistan, the Chinook, we just love it, right? It's so good. So yeah, at the time it was funny because I was in the talk, one of the pilots, the Griffin pilots kept coming in and kept complaining that the Chinook was always going too fast or was like in a combat zone and you just want to get from point A to point B. And they kept trying to tell the pilot to slow down because it's like counterintuitive. You'd think that the little sporty looking helicopter is really fast, but the big bus is actually, the big machine. I guess what I wanted to do is just talk about you and in the vaguest of terms or however you like. And then we'll go over and fly some fake helicopters. Okay. So as a Canadian Air Force pilot, you're an officer and you spend years of university at recruitment, and you'd usually begin your pilot training then. Would you begin your training like year one, or is it that you would do normal university and then specialize after that?
So went to school for a couple of years after I enrolled, and then after my second year, we started pilot training. And you would go to Portage la Prairie in Manitoba, and you'd fly. At the time, it was a Slingsby Firefly. Now they fly Grobs, which are just little single-engine acrobatic aircraft. It's a short, like an 8-week course, 30 hours of flying, and it sort of initiates you into aviation. And it is a bit of a selection course where there's a relatively high failure rate, or there used to be a relatively high failure rate. And that's how you start. And then there was a couple more years of school, and then I went into a basic flying training, they call it, but it's actually on a turbojet, a turboprop helicopter, or a turboprop aircraft. Thanks.
So that is still a thing. You always do fixed and then rotor.
Yeah, so every Canadian Air Force pilot will do the initial flying training on the Grob, and they all go through the Harvard 2. It's also known as the Texan 2 in the States. And you do about 100 hours on that. It takes you about 9 months to a year to get through that course, and that includes formation and low-level navigation, that kind of stuff. And at the end of that, you still don't have your wings. You're selected to either go for fast jet, so you go stream towards the fighter aircraft. There's a stream that goes for multi-engine, and there's a stream that goes to chopper.
When you joined, did you plan on making it a full career, or was it going to be like an intermediate for a civilian job?
Yeah, I don't know. I think most of us sort of stumbled into the things we were doing. I started in the infantry as a reservist. And then after my 90th section attack of the day, I sat an F-18 below over top of my position and decided I'm going to make a change. Right.
Did you have any prior experience before joining?
No, I had no flying experience at all. And it was one of these things that I hadn't really thought about as a kid. I went into the recruiting center, and the guy looked at my sort of, I guess, math scores or whatever and said, you qualify for pilot. Do you want to go to aircrew selection? And I was like, yeah, sure, I'll go to aircrew selection. Why not? So I went to Toronto at the time, and we did this is a simulator that you would do, and you don't really quite know how well you do. There's a whole bunch of sort of rapid math tests, and at the end they tell you if you were selected for pilot or not. And I was lucky enough to get selected. So
nice. So throughout your career, can you tell me what airframes you were qualified on, in what order? I guess starting from the beginning.
Yeah. So I went through on the Firefly, so a little light aircraft. And then the T6 Harvard 2. From there, went into the Jet Ranger, flew the Jet Ranger for about 100 hours, and they got my wings on the Jet Ranger. And then from there, you get your wings, and you go to your first operational unit. And then at that point, I got trained on the Griffin, the CH-146 Griffin, to Bell 412. This is about a 70-hour course, 70-hour flying course, which really brings you from the basics of flying the aircraft all the way through to tactical employment, night vision goggles, formation at night, that kind of stuff. You graduate that course and you're a co-pilot. And so back to my squadron as a co-pilot for about 2 years as you sort of gain experience, deployed overseas to Bosnia. And then at a certain point, they sort of judge that you're sort of ready to try and upgrade to aircraft captain. You go through a whole sort of process to upgrade, and I completed my upgrade.
So just a leading question. As a co-pilot, the main pilot obviously is in charge. Do they often just give you the stick as your...
Oh yeah, so the pilot-co-pilot thing really means who's signing for the aircraft and is responsible for that crew. But it does not imply who's flying or not flying. To be honest, as an aircraft captain, I found I flew less and managed the mission more, and I had my co-pilots fly, and you're just more directive. It really depends on your styling and then again the kind of mission you're flying. Right. And then after the Griffin, I went into the special operations world, flew for them for a while, and then I went into Chinooks. So I flew D-model Chinooks in Afghanistan and then F-ball.
Was that a natural leap, or was that some kind of crazy different learning skill?
Yeah, I mean, the hands and feet of it are simple, I would say. Like flying a Chinook, it's a more stable aircraft than a Griffin. It's an easier aircraft to fly. You get very lazy, your feet, you don't have to work the pedals as much. And so I do find Griffin pilots are more precise pilots. They certainly have to be more exact in making sure they're not exceeding aircraft limitations. The Chinook, you can be a bit lazy in the sense that you have so much power, and you don't have to worry about wind nearly as much or the tail rotor. And so I think the hardest aircraft to fly was probably the Jet Ranger at the time, and then the Griffin tactically is the most challenging aircraft to fly.
It's funny because we're going to talk about power to weight ratio versus ease of flight later on, because that's something I've also noticed as a nobody. Were there any opportunities throughout your career as being a co-pilot in another platform, kind of on an exchange, so like a not one of your helicopters that you're qualified on, is that something that you would get to do as a pilot on an exchange, be able to co-seat an unusual helicopter, or is that something that they would just say no?
No, so we have a bunch of standing exchanges with other militaries, mostly Five Eyes militaries plus France. Right. And so we have guys and girls who are out flying for them, and they do 2 to 3 years. We'll post over there with their family. They'll conduct the operational training course with that country, and they'll fly as rated aircrew. My experience was that when we did the D model Chinook conversion, we did it through the U.S. Army. So the U.S. Army taught us how to fly those Chinooks. We did the U.S. Army course, and then as part of our sort of work up to Afghanistan, they sent us for 2 weeks with a National Guard unit in the States, and all different Guard units in every state. So
exercised.
It was to take sort of the basics that you got on the course and sort of translate it into how do I operationally employ the airplane. Okay. Tremendous training course. The U.S. Army produces volumes of pilots at a very high standard. Yeah, they're good.
So DCS is the program we're going to use tonight, is Digital Combat Simulator, and I've been playing with the Mi-8 and the UH-1. These are the two choppers that I've downloaded. Tonight we're going to be flying the UH-1. I noticed a major difference in how easy it is to fly the UH-1 compared to the Mi-8, and I think it has to do with available power to weight ratio and like it's how acrobatic the chopper is or how strong it is. And I'm going to be downloading UH-60, and I'm actually expecting that chopper to be even easier to fly because it's more modern. It has better automations or assists, I guess, like stability and stuff like that. So you already kind of led into it. You basically said that the Griffin is a much harder, less relaxing experience to fly. I want to choose my words because hard is not the right word. And yeah, which did you find more rewarding to fly, the Griffin or the Chinook?
So I flew 2 models of Chinook. The most recent version is the Foxtrot model. Canada bought those in about 2013, and it has a dual digital automatic flight control system and all kinds of automation in it. And it's great because it really reduces your workload as a pilot and really allows you to sort of manage your mission and have great situational awareness because all that work that you were doing to keep the airplane stable is being taken care of in some regards by some of the computers. Right. I think my favorite aircraft to fly was the Foxtrot, hands down. Yeah. Just because of the automation and your sort of complete understanding of what is around you and what's going on around you. The Griffin's a very satisfying aircraft to fly, but it requires your eye scanning in the cockpit to make sure that you're not exceeding anything in terms of the aircraft parameters.
It'll let you get more reckless.
Well, I'll give the Griffin credit in the sense that it's sort of maligned as it's underpowered sometimes, but the aircraft will give you way more power than you're supposed to get. Okay. So if you're in a bad situation, and many of us have gotten these situations, it will get you out of them. It'll break itself getting you out of them. You can overspeed it, you can over torque it, but it will deliver that to you. There are aircraft out there that have limiters on them. That as you get close to a limit, it will fuel limit and you'll start to reduce your rotor RPM.
That must not be a very comfortable feeling.
No, there's no way out, right? You're sort of got yourself in a bench.
I need more. Yeah. So there's no veto. So yeah, many of the viewers know very little about what we're actually discussing. So I'd like to know if you could take me through the what you're expecting, which is the basic controls that you have and how they affect the aircraft in flight.
Sure, I guess we'll sort of use the single rotor helicopter as the basis, and so you really have you have a number of controls at your hands. You have the cyclic, and it does just that. It changes the pitch of the rotors cyclically as they move around the disc, and so but think of the disc as a lifting surface as a disc. So if you push forward on the stick, you're going to tilt that disc forward, and your lift vector is going to be tilted aft, and you're going to move forward. So it's pretty intuitive. The collective on your left hand, it changes the pitch of the blades collectively all at the same time. So taking a greater bite of the air, obviously that would allow you to move up or down using your left hand. On the collective, especially in Huey variant helicopters, there's throttles, like a motorcycle throttle. And we typically would have the aircraft at 100% rotor RPM to give you the sort of most optimal amount of lift for any given situation. There are instances where you would reduce that rotor RPM to a low end, which is usually about 97 rotor, and there are instances when you might want it higher, up to 101.5% of rotor RPM, and that's really linked to if you have tail rotor problems. If you were coming in with the tail rotor problem, you can use that rotor RPM to your advantage. So there's engine parameters, there's temperatures and speeds for the various turbines, the power turbine, the compressor that you're sort of monitoring with one eye, and there's engine torque you're monitoring with one eye because there's limitations. And then there's the rotor system itself, and so you'll be monitoring the speed of that rotor system, so you always kind of want it at 100. And you're monitoring the torque you're applying. It's typically 0 to 100%. Some of the European helicopters have this great indicator. It's just a 0 to 10 gauge, and they call it the FLI, or the first limitation indicator. On a given day, if it's hot or you're at a high altitude, you're going to hit a different limit first, be it engine torque, be it temperature on your engine, or be the compressor speed. And so any one of those on any given day, depending on the atmospheric conditions, can be your limit. And so some of the European helicopters have this FLI, and it's very, very useful, 0 to 10. It's easy for pilots. You don't have to worry about looking at 3 gauges.
Just say, I'm good to go, or I'm not. Yeah, I notice anytime you change any input on a helicopter, unlike a plane, the plane does it somewhat, but anytime you move something on a helicopter, something else moves out. Like something else needs to be moved as well. Yeah. It's kind of like a more fluid, like a ballet. So like pushing forward moves you forward, but you lose altitude. Pulling up on the collective also applies torque on the rotor, and that changes the orientation of the helicopter. So there must be a point at which that becomes intuitive or more automatic. Is that early on in your flight school where you just pick it up and it's...
No, it's quite late in your training, because I'll be honest, when we learn how to fly airplanes, you get quite confident flying airplanes. They put you in a helicopter and it's like a whole new environment. And I remember coming back from my first flights and my hands were soaked. Like you're sweating through your hands, your gloves are soaked. But you get comfortable with it pretty quickly. And there's a bunch of exercises you do throughout your training, and even when you get on your operational training unit, where they make you look sort of out your window or with a door off, and you were looking off axis and trying to hold hover references. Okay. When they first introduce hovering to you, they usually give you a 45-degree reference left or right, depending on where you're sitting. And you try and use that 45 reference because it gives you the best appreciation of forward and aft drift, left, right drift, and then trying to appreciate like an object in the distance that would give you that sensation of moving up or down, and then scanning inside of the cockpit to get those parameters. We've done a few things in military aircraft that help, which is a heads-up display. So in the Griffin and the Chinook, we have day and night heads-up displays that go over one eyeball, that flip down off your helmet and allow you to basically have compass heading, all of your engine parameters, torque setting, your next waypoint, distances to next waypoint. All that can be over one of your eyes.
Does that work like the monocle on the Apache?
Yeah, that's a PNVS. It's a thermal imaging system. This is just more like a clear filter, like you get in these high-end cars now. These little HUDs.
So it's like augmented reality. It just shows you more data.
You bet. And it's a big cable attached to your head. So it's an old school variant of this. But I'll tell you, like very, very useful if you're trying to hover, looking sideways. If your only reference, let's say, is at 90 degrees, and you're looking 90 degrees to the side, having all that information on one eye can be very useful because you can start scanning inside of your...
Right. You can multitask. Yeah. That's cool. We're going to get into maybe some more technical questions.
Sure.
So when hovering or flying, if you have troops moving around, I know in Chinook, it's more possible for people to move around. But I know like if people are getting ready to rappel and dispatch, the people moving in the helicopter, you're trying to hover, that must have an effect. How much of an extra workload do you think that adds to you? Like, is it intuitive that you just kind of counteract it, or do you really have to work?
So you have to work a bit harder, I think. It depends on how dynamic the maneuver is. So I think about, there was one maneuver we do called helocasting out of the Griffin, where you have typically combat divers or soft guys on the side, and you do a very slow sort of a 10-knot hover taxi at about 10 feet. So we call it 10 knots, 10 feet. Right. And they're dispatching out the side, usually with flippers or whatever, to go and do some sort of littoral thing. In the Griffin, you really, by the last 2 or 3 guys are typically at 20 feet because that weight being moved out of the aircraft causes you to climb, and unless you're proactively counteracting it.
So it sucks to be last is what you're saying.
I would never sign up to be the last guy. So in the Griffin, you definitely feel the weight changes of 200 to 300 pound people leaving the aircraft. The Chinook, it's much less obvious that they're leaving the aircraft just because the power margin is so big, and it's a 50,000 pound helicopter and a 300 pound person, as opposed to an 11,900 pound helicopter and a 300 pound person. So there's a big difference.
The delta is definitely not the same. So I know that most helicopters can sling. The thing that I liked the most about the Chinook when I looked at it is how deliberate the sling port is. Like there's a hole in the floor and it's up on the backbone of the chopper, not even slung to the floor. It's actually very, very cool. So I guess, is there any magic to carrying a slung load to make it manageable? Like I can imagine it could get to a point where it's oscillating. Is that something that really happens a lot?
Yeah, it does. And you can just imagine every load has its own sort of characteristics. So even when when we were practicing slinging, there's a whole checklist to make sure that you've done the right things, that it's hooked up correctly. But then as you give your brief, the great thing about slinging is you can give it back. You can say goodbye to it if things get really unstable. Right. And usually there's a button you can push or a manual release you have in front of you. But we always sort of would verbalize that we test fly the loads. So at every increasing airspeed, typically at least in the Griffin, if it's a single point load on a single tether, it can become dynamically unstable and start to oscillate. And every object kind of has its happy speed. Right. And so we would test fly the load. I would say 30 knots how's the load, 40 knots how's the load, and the FV would be stable, oscillating left to right 2 feet. And then the way to stabilize the load is typically apply a bit of G. So if you turned the aircraft and applied a bit of collective, you can stabilize the load. Or if you reduce your airspeed a bit, it will stabilize the load. In the Chinook, we could do tandem slinging. So it's really having 2 points of connection, and it's incredibly stable. You can go very fast. And so I would typically try and tandem sling everything we could, especially in Afghanistan. We would move guns a lot, artillery pieces, M777s, and it's a 12 or 11,000 pound load, but it flies like super stable. It will not oscillate at all.
That was I think the biggest difference between Bosnia and Afghanistan that I noticed is that in Bosnia we were driving everywhere, and in Afghanistan our lessons learned, we just said it's not worth it. We had better control over the airspace, and everything was more things were flown around. So that
things were flown. I mean, the biggest challenge in Afghanistan was dust and recirculating dust. Right. It's not unlike Canada in the winter where we have recirculating snow, but the dust just persists and gets worse and worse. So we did a lot of long line slinging there where you had like 110 feet of sling. Mm-hmm. And if you were to put it in a dusty fob, you'd put it on the ground just as you get enveloped in the dust ball and then release it and leave. So we use that extra sling length, obviously, to get ourselves away from the ground.
Yeah, as a geotech, I would help site landing zones. And it was always that prevailing wind and almost a glide path, like you were saying, so that you could touch down, offload, but be kind of moving in a direction so that you would never suffocate your engines, right, with the dust.
Yeah, we had engine protection on the Chinook, but certainly it's a concern, obviously, operating a recirculating phenomenon. Yeah.
I just like how nuanced flying chopper is, right? You're in an airplane, it's all up there. You don't have to worry about all of this other stuff, like getting really close to the ground. So when you're flying a chopper, do you feel, obviously there's a combination, but do you feel the feeling is more important than the look, or could you give like a mathematical ratio between how much of your flying is what you feel and what you can actually see?
I think it becomes, it's art and science. You get taught science at the start, how to mechanically fly the airplane. And after a certain number of hours, and I can't say how many, I think it just becomes intuitive. You start sort of realizing or feeling what is right and what is not right, like a weird vibration, especially in a Chinook. Right. You will get weird vibrations and you're like, why is that occurring? Right. I also think that the reliance on using instruments to fly in a VFR, visual flight rule sort of scenario, we do teach guys to attitude fly, so to sort of pick, what is that height above the horizon or below the horizon that the dashboard should be at, and keeping your eyes out. You can maintain a level attitude, not climb or descend, once you get sort of that intuitive feel of what it's supposed to look like and feel like.
It's funny how, so I used to tune and race a sport compact car.
Oh yeah.
So 400 horsepower hot hatch, and it was funny. I could tell when the oil was low because you could hear the engine cavitating. You get so familiar, so embedded in the actual experience of whatever, that you'd know if your tire was low or something like that. So it's interesting to hear that that's the same thing.
So even in the Chinook, we had this 30-minute check or a ramp check, ramp cabin check, that the FE, the flight engineer, would come forward. He checks the maintenance panel, and then there's a whole number of areas where he just puts his hand against the airframe, or her hand against the airframe, and lets it, and feels the vibration. And if there's a drive shaft starting to come apart, you can start to feel it. And so every 30 minutes, there's this tour that occurs in the back, with the flight engineer using a bit of an old school methodology. Yeah.
That's fantastic. And that's mastery, right? What was it, 10,000 hours of doing something and you're the master? So just with proficiency, and this is why everyone stays in their lanes and does their jobs, and you trust your team, right? Like that's the same thing. Someone in the back tells you there's something wrong with the bird. You don't just say, nah, it's all in your head.
No, it's
right?
a team sport.
Definitely,
in helicopter.
Definitely there.
Sport.
Okay, so you kind of touched on night vision a little bit. It would make sense that your NVGs would be stereo so that you'd have more depth perception, because I've used both, and it was like a paradigm shift when I got to see bifocal. I'm wow, that's it's not the same. It basically becomes almost like day. There's less learning curve associated with it. So do you find that it's that flying chopper at night with NVGs is like kind of that seamless, or are there complications beyond just vision that are?
Like it, excuse me, it takes a while to get used to. It takes about 30 or 40 hours, I think, a goggle till you really get comfortable. And the big issue is sort of building that picture for yourself of what is outside. Because all you have is now, you go from 210, 220 degrees with your peripheral vision of what you can see down to 40. And so what you see through your two monocles or your binocular NVGs is about 40 degrees. And it's monochromatic too, so you don't have a lot of depth perception. And so you have to rely on certain cues you get used to. So scanning your head in sort of a methodical way to build yourself that picture that you would get out of 210 is one. And then obviously sharing your attention between what is outside and what is happening in the cockpit, and managing your lighting to make sure that your eyes can still see what you need to see in the cockpit. Or we do put HUDs over top of one monocle on the NVG. So you do have a HUD display on one of your NVGs. Neck strain is a big issue for helicopter pilots who fly goggles. Yeah, it's a couple pounds, right? On the end, it's on the moment arm of about, 4 or 5 inches. And then a lot of us would put weights on the back of our helmet to bring it back up, which actually is, now it crushes your spine. And so I have a lot of friends who have got degenerative disc issues as a result of a lot of goggle flying. But you do get really used to it, and the more you do, it's a very perishable skill, but the more you do, the better you get. And during my deployed time in Afghanistan or doing a lot of domestic stuff on goggles, you get really good at it really fast.
It's interesting to hear that there's still that learning curve, because I was an armored crewman for 15 years, and of course driving tank during the day, you have 3 periscopes or episcopes, and you get very used to what that is. So you can see an obstacle, and then in about 10 seconds based on your speed, you're going to hit it and how to approach it, and you get really proficient. You get that mastery. But as soon as you do night, you're limited to a single, because the apparatus is super expensive. They only give you one. Yeah. So you're doing that where you're driving, and to get what you're talking about, your peripheral, you're actually going to skid steer left and right to kind of see what, put the feelers out. So it's actually really hilarious to hear how common our problems are, or
well, and so we have a limitation in terms of how close you can get to objects. So for the Air Force, we have a half rotor rule. So if the rotor for the Griffin is 46 feet diameter, so you're allowed an obstacle no closer than 23 feet from the edge of the tip of the rotor blade. And you can see it really markedly at night. You can see where the end of your rotor blade is.
Is there a light?
No, there are tip lights. Some aircraft have tip lights. The Griffin doesn't have tip lights, but you can really see it. It's very, very obvious where the edge of it is. Yeah. And every single night flight, typically, we would land and confirm our half rotor. So you'd land and say, okay, that bush right there, is that my half rotor? And then the FE will pace it out and say, you are short, you are long, and we would recalibrate ourselves every single flight.
It was at this point during our talk that the 30-minute timer on Canon cameras decided to shut the camera off. Once we realized, we continued, and that's why there's a break.
I would like to know, in very basic terms, before we move over to the simulation, I wanted to know what types of previous simulation gear you maybe have used from very basic to immersive, just so I can get a frame of reference.
Yeah, for sure. So like I said, we do use really basic stuff like printed replicas of the cockpit, and we use those in our rooms as students as you're trying to learn the aircraft and learn your checklists, bouncing like a ball against the wall while you're reciting checklists and using these little mock-ups, all the way through to we call cockpit procedures trainers, which are a full mock-up of the cockpit with all the switches but no actual simulation. But it allows you to use the tactile aspects of the cockpit and sort of benchmark where your hands should be going in emergencies. And we have those at all of our schools. And then there is simulators, which are fixed-based sims. So I think back to Moose Jaw for the Harvard and the Hawk. It's just a simulator in a room, not unlike what you have, which has wraparound screens. And it's pretty immersive, like the entire cockpit's replicated and you have a great visual representation. And then as you sort of gain in aircraft complexity, you move into full motion simulators with collimated displays. So it allows you to get that sensation of acceleration, deceleration in the cockpit. I will say, like with the way, I used to be convinced you had to have motion to really get the experience, the immersive experience. But the visuals have come so far in the last number of years, and the screens and the graphic detail is so good now that you can get pretty immersed without having, I think, some of those weird cues that your ears would need. So now most of the helicopter simulators, the newer ones we're looking to acquire, they are non-motion, but have cueing, like seat cueing that moves the seat around a little bit and has some vibration in it. But the visuals really bring you there. Okay. And so I've used all of those all the way through to full motion. And
so in the future, I'm going to invite you over because there's a new sim rig coming, which is 6 Degree of Freedom, not 3, and VR. I'm trying to incorporate both. I'm a firm believer that the most immersive visual experience is the 3D environment of VR. You lose some resolution, and it is, like you said, we talked about NVGs, how it's a contraption on your head. But I've already tested it. Spoiler, it's really good. Oh, yeah. It's really good. So I imagine, like you're saying, you were doing your 45. You can do 45 on 3 screen, but to actually look out the side or look down out that little glass that's by your feet, that must be really, really big. Okay, so what we're going to do is take a little break now. We'll get some water, and then we'll get spooled up on the simulation rig, and we'll talk about more stuff. Sure. Awesome. Good.
After that great talk, we moved over to the sim rig.
Feel free to talk to me and tell me what you think as you're flying, please.
All right. Holy. Okay. Oh yeah, you can see the stick replicating over there. Okay. Just want to see what the controls do there.
Hopefully everything just works. That would be ideal, right?
Rotor RPM. That must be in. Oh, this is an old. So the rotor RPM is not in percentages. I think it's in like pounds. Foot-pounds or something like that. It's. Anyways, we'll go with it. We'll use the green arc. So a little bit of power, bit of pedal. Get up in the hover. Yeah.
That's a lot better than my takeoff.
Is it?
Yeah.
Let's try not to drift back. More forward cyclic than I thought you need.
And if at any time I'm also interested in you telling me how far the collective has to come up to get a certain amount of performance. If that's too much or too little.
This is pretty good. I mean, it's a we call this PIO, pilot induced oscillation.
Right.
It's just as you get used to the controls, but that's a pretty good hover. So it's a little bit pitchy.
Like too aggressive? Do you mean?
Yeah, it's just a sensitive in pitch.
Okay. So that's something I can actually tune out. I can actually make the stick a little bit dumber. Not necessarily adding a dead zone.
So I'm slowly drifting back, right, and I think it's because the nose down attitude is more significant than I'd be used to. Like that attitude that you need to hover right now, it feels like an accelerative attitude to me.
Okay.
So I'm just gonna get into forward flight here and just move forward. That feels like I'm way pitched down there.
Now this game, because I'm going to call it a game, DCS does this funny thing when you're overtaxing the chopper. It shakes the entire console. That's like the visual cue that there's something wrong with what you're doing. So you were talking about having a beep. Yeah. That's this game's. And again, I'm also curious to know about. Obviously, the motion is a big part of today, right? Because
the motion's good. Like this is pretty representative, I think, of the sort of waddle you get. I'm just trying to get a tactical altitude here. So I'm looking at my radar altimeter, if there is one. No, there's not.
So you have, you should have in the center. There's 145. That's your.
So I've got vertical speed. I got the altitude on the top right corner there. I've got my attitude indicator in the middle, which is, and they're replicating almost perfectly. Yeah. Their speed, I'm at 80 knots. And
so
I'm in the green arc.
What's in the middle?
Oh, there. That's the rattle. Yeah, you're right.
So I think that's. I hope that's radar.
That's a rattle.
Yeah, that's straight to.
And you can set the bug to ping, and we typically set it at like depending on the phase of flight that you're in.
So remember, the Russian helicopter was much more vocal than the American helicopter. When you were doing something like close to ground, it was constant. It was just, and I couldn't figure out how to turn it off. So the joke is in this game, in this simulator, you can mess with all the dials like you were talking about.
Really?
That's next level stuff. Again, this is just kind of like a.
Yeah, the rattle. Now that I see it in my scan, is replicating pretty much perfectly.
Nice.
Yeah, that's awesome. I see I climbed 100 feet in the turn there. Yeah, this is really cool, Brian. I'll tell you, like, it feels very realistic.
Nice.
Like the little waddle of the aircraft, that's very, very representative of a Huey or a Griffin.
Well, it's a lot smoother. Like it took me about 10 hours to get to a normal level of proficiency where I could actually pick and choose where I wanted to go. But that hover that you pulled off right at the beginning, I still can't do that, wow. By the way. And that's...
the thing with simulation too is, I think you would notice, you get used to the control touch the more you do it. But in simulation, I've not really met a helicopter simulator that does hover well. Even the big, really expensive commercial ones are always challenged with like the attitude. And so like, I'm just gonna try a deceleration here. Bring the nose up and drop the collective a little bit. But this is actually pretty good, like in terms of the hover references you get. Is there one on landing? Oh, there's a flip. Okay, try to do a run on. Can I reset?
Yes, of course.
All right.
Yeah, no one needs to be upside down.
It's funny though, like in simulation, you get pretty immersed, especially when you have the full cockpit around you and stuff, and it's at night. And I've actually, as we crashed in the simulator, because it's always a crash and burn when you're in the sim, you're practicing emergencies. I'm going to do a no hover takeoff. So you put a bit of nose down, full collective. There you go. No hover, straight ahead. Yeah, it's a pitchy attitude. It's a bit, I'll get used to it, but it's a bit more nose down then. No, that's pretty good actually.
So I'm going to try to articulate what I think you're telling me. You're saying that the amount of stick that you need to make the helicopter do something sensational is very, very sharp.
No, it's a sensitive cyclic, but it's actually very representative. The attitude of the helicopter, so like a lot of that hover, holding your hover attitude,
yes,
is visual. So I'm not even looking at the instruments, I'm just looking outside for references for drift. So I'll just slow down and do a hover here. And maybe I'll use the intersection right in front of me here. And so as you settle into the hover and you add all that extra power, oh, that's weird. See that's rotor droop?
Yeah.
What I was able to do at this time was to go into the menu and adjust the curves for Y, cyclic, to make it a little bit less sharp. And then Chris confirmed that made it better, that it flew more normal.
Because my question then is, I never manipulate the throttle. You're actually manipulating the throttle while you're flying? No, okay.
No. Okay. You set it at 100%, you leave it alone.
Okay, good. Because I always, when I was reviewing this device, the collective, I was like, I feel like I'm only using 10% of it. Like it's up and down. Like
no, it's you only really manipulate the throttle on the start.
Okay.
Or if you have an issue with a tail rotor, and you have to manage that. Or if you have an issue with a fuel governor, you sometimes have to manually use the throttle to meter the fuel in.
Right.
If you have a fuel governor failure.
Because what we're doing right now is just the quick fly, and that's it'll be very, very frustrating for many of my viewers to watch because everyone likes to go through the buttons and the procedure, right, of pushing buttons. But
see, that's a really representative no hover takeoff right there.
That was nice and smooth. Oh.
So yeah, so there's an aerodynamic thing called flap back. As you get out of effective translational lift, you have to apply what might feel like too much forward cyclic too fast to maintain your forward accelerative attitude. And that was actually simulated pretty well in here, where I had to do a progressive push on my cyclic to maintain my momentum forward.
So it's like you hit a fake brick wall, like a jello wall, and you have to push through it?
It's just as you're moving through that effective translational lift, there's an effect called flap back, where you have to physically sort of push through it with the cyclic on a Huey variant helicopter, a single rotor helicopter.
Do you feel that the pedals are more sensitive than they need to be?
No, the pedals are incredibly sensitive in any one of these helicopters.
Okay.
And I think they're very representative of the sensitivity. I'll try and do a pedal. I'll come and do a hover here, and I'll try and do a pedal turn just to see.
So that you're talking about another thing that I can't do that. Like, and again, this might also be that this chopper is underpowered compared to what you're used to.
No, it's not the power. I think it's just also it's the amount of control inputs you got to do, and linking it back to sort of what I'm used to. So I'm at about 150 feet here, which is kind of high. So I'm going to move down.
You also have the reverse of me, where I'm learning how to play a game. You are a pilot, and you're trying to learn the game. You know, like it's kind of...
The final strokes on that are, for some reason, odd. Yeah, like I bet you with the practice you're going to have, you're going to get really, really proficient at this. Yeah, the rates of control application in the cyclic are tricky. I'm going to try doing a pedal turn here. You can see how pitchy I am forward now.
So you're doing something like witchcraft for me. I can't. I can barely hover without breaking the helicopter.
Yeah,
so
it's just the control.
What you're doing
it's
is
the
actually,
magnitude of the inputs to get what I want it to do.
It is still very impressive that, like, you're giving me a challenge now.
So there's this thing we would do with I'm just going to try and fly out of this just because it's gotten a little unstable. There's a thing we would do with sort of using new copilots, and it's called pirouettes. And you sort of track a line down the runway while doing pedal turns.
Oh, man.
Let's see if I can do that.
Don't even.
It's tricky because you got to fly over your shoulder.
So
if I start tracking down the runway.
I don't think I'm going to be breaking OPSEC, but I was just in Kuwait, which was not a secret. And the local Air Force used their Apaches to clean the runway because it was so dusty all the time. And it was cute because they would fly straight down it, and then every once in a while you'd get a pilot who was feeling a little saucy, decided to fly down it sideways. And my 2IC was like, well, that's not a big deal. I'm like, I think that's a pretty big deal. I think that's chopper's not necessarily not designed to go sideways.
Well, it can go sideways. There's always a sideward limit just based on what the tail rotor can handle.
I guess I'm saying I was more impressed than he was.
So let's just see. I'm going to track this way, and I'm going to put right pedal in.
But so far, all the inputs are like you push the correct way and it moves the correct way.
You know what's funny? The pedals right now, what is happening is it's almost like a rudder input where it only gives me certain travel. Like right now, if I have full right pedal, I should be rotating.
Do you think it's because do you think there's some kind of automation that's built into this helicopter that's because you transitioned to forward flight?
That might be it. Let me just see if I can stop entirely.
It's probably something I can turn off. But this always happens to me too. It always, yeah.
All right, let's try. So there's something weird there because I should have been able to sort of spin the aircraft around as I was tracking.
There's probably something in the setting that one of my viewers is going to be like, you moron, you're supposed to push button whatever to get rid of, like to disable auto hover or something like that.
Want to try an auto rotation? Yeah. No, I mean, I'll be honest, like most of us have a hard time landing autos in our super high-end sim. This is actually really good because you get the ground rush and you're getting all the cues you need on the sides. It's really, really impressive.
But this in VR, do you think it would be simpler to do in VR or easier because you can actually look down? Yeah. I'm assuming you're losing some of your peripheral here. You're losing some cue, right?
Yeah, you are. It's pretty immersive though, Brian. Like there's a no hover departure, and I'm getting used to it, right? The control touch that you need for this aircraft.
Yeah.
So good acceleration. There's 40 knots through ETL.
I think that was the smoothest takeoff I've ever seen on this thing, by the way.
Yeah, thanks, buddy. You just get used to it. So we'll get up to 8,900 feet again, and then we'll say practice engine failure. Roll the throttle off. We'll drop the collective down. We're going to watch the rotor. I'm going to check to see what the motors are doing. Make sure the ball's in the center, and then get our airspeed sorted. Okay, I'm really slow now. So I don't know what happened there. 40 knots, 50 knots. Keep on trucking. Bring in some more power. There we go. So you know what's funny, like we do auto rotations in the actual aircraft and we do power recoveries. And so you'll roll the throttle up and fly out of it.
Okay.
At a minimum altitude, we usually use about 150 feet on the Griffin.
This is fantastic. Thank you so much for coming over.
This is so cool. This is so immersive, actually. And the detail on the graphics is better than the sims we fly in.
Don't tell anybody. But so the game itself was only $60.
Is it really?
Yeah.
I'm just trying to find my, the torque's in pressure. Okay.
So what I'm actually, I'll preface the next visit if you decide to come back with the 6 degree of freedom, because this does pitch and roll and some heave. What I know it's not giving me is the twisting rotation that you that kind of off axis.
Yeah.
So and then there's that feeling that you get when your bank rate isn't enough to keep you in a curve that you start to fall sideways. So having the extra, well, first of all, this is only 10 centimeters of travel. The other one is 40 centimeters in any direction. So it's actually it can move you a lot more, but it can also move you in different ways that this one can't. I really like this. I'm expecting the other one, which is 4 times the cost, to hopefully give you.
Yeah, I'll try a different one. Okay, value. So we're at 1,500 feet. So I'm going to do a terrain. Practice engine failure. Fluxes on the ground. Rotor's good. Check it. Motor's in the line. Ball's in center. Airspeed's good. Here's my turn. So keep a bit of nose down in the turn. Yeah, see my airspeed's more stable this time. Rotor's spooling though. You can see it, eh?
Right. Yeah, it really wants to go. You're giving it a lot of energy.
Okay, airspeed's good though. And there's 500 feet. So we'll just take it into this field straight ahead. 60 knots. See, it's that pitchiness. 300, 200, 100. Flare, 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 flare. Check pause level.
Oh, that looked, yeah, that was,
it's hard to judge the last 20 feet.
Yeah.
I'll do a low level if you want. I can try low level.
Yeah, so this is the thing that I like the most, is just take off and try to get moving as forward fast as possible and getting in between urban structures.
Oh, okay, I could try that. I'll go over there.
No, because they're actual cities. You fly straight long enough, you'll find a city, like follow a road just like you would. Again, no specific destination, but eventually you'll get into upper urban, and I just like see how there's like a whole factory, a full set of town there. I don't think it's really teaching me how to fly well, but it's definitely fun, right? It's kind of like, the classic thing is, I think a friend of mine said, every single time you get into a flying game, you turn it into pod racing, right?
Yeah, like, exactly.
Even like flying a Cessna over New York, no, Brian has to be in New York, right? So, driving down the street.
So if you're flying over contour like this, what you normally do is keep your attitude the same. So your pitch with your cyclic, you keep that as a constant for a given airspeed.
Right.
So let's say we're flying 90 knots now. But if you want to rise and fall with the terrain, you use your collective for climb. So there's a bit of a lag. So you got to sort of anticipate your climb and descents a bit more, but it makes a much more even flight path.
Yeah, because I'm doing I think I found a bad habit that I realize that you can only pitch so much forward before you run out of collective, right? Like you'll still crash.
Yeah, you'll fall off the bubble there.
Right.
Yeah.
So there's that one, and when I get really bad, like when I'm about to hit a building and I've completely misjudged it, I pull the cyclic back a little bit to bring the nose up, and I find, like, I guess I'm trading horizontal speed for vertical speed at that point, because sometimes there's just not enough collective to stop me from crashing.
Well, yeah, and that's the hardest part here, I think, is the last sort of 60, 50 feet.
Yeah.
I mean, the nose down attitude for the hover, I'm not sure you can change that, just sort of a graphics thing.
Right.
So I'll try low level auto here. So I'll get back down to like 50 feet, skimming along. And all you do is get into an immediate progressive flare. So let's call it 50, 60 feet. Okay, so practice, and we're at about 80 knots. Practice engine failure, drop the collective, bring the nose up. Flare, 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 flare. Check pause level.
Yeah, that was
actually way better.
Yeah,
there we go.
So what I liked about that is it looked to me like you were too far over, but the amount of aggression that you did in it was exactly, you needed to zero your forward speed. I'm going to shut this off so that you get...
That's okay, it's going to ramp back up.
Oh, okay.
Just go back in. Okay. I'm actually going to...
I'll resume.
Yeah, because look, just watch my rotor. It's going to come back up. I just snapped the throttle up.
Nice. So, yeah, it was... I don't have enough... I never throw enough balls into the situation. You really zeroed speed. You came up like 45 degrees.
Yeah, you really have to be aggressive. I'll do another one of those. So you flare, 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 and at a certain point when that flare has sort of had its effect,
yeah,
and you check, you do a little bump on the collective, that kind of pauses you in the air, you level the aircraft, and then as it sinks, you cushion, cushion, cushion. So that's, we'll try that again.
Yeah, I think that I'm too slow, and that means that I scrub all of my, I lose all of my energy, and then I become a piano, as you say.
It's tough. It's tough to judge the height on this. So you got to use your rad alt a bit. So there's 50 feet. Stepping along tactically, 80 knots-ish.
This game works really well in VR, and I think, like I said, the next, I'm hoping to entice you for 4 different visits. Obviously, you can come as many times as you like. You can log as much flight time as you want.
Practice engine failure. There's the.
But there's this.
Come on. One flare. There we go. Okay.
Wow, look at the
Check.
angle.
Pause.
Nice. That
Level. Cushion.
So that's
it's
still
really
engine.
quite sensitive. There we go. On there.
Walk away from it. That's fantastic.
Well, I can count on my hands the number of times I've landed at a low level in our simulator, so that's pretty good.
That's nuts.
Yeah. I'll try it. I want to try it turning again if you don't mind. Can I try one more?
Yeah. I am retired.
This is pretty cool. Like, it's actually really, really good, Brian. Like,
yeah.
Yeah, I'll try and know how we're aggressive here.
I'm happy that that it's living up to expectations, because
obviously
it's the kind of thing you don't ever want someone to say what you bought is garbage.
No, this is very good. Like I do feel like it'd be a great procedural trainer for someone learning.
So what I like about this also is all I've done is the motion platform itself. I've set it to 80% of the default. I've just taken the game across the board and just brought it down. I did that because I was finding a lot of input. So you would pitch, and then the platform would move so much that it would move your body too much, and it would move your joystick again, and it caused unwanted kind of motion. And it's not that it wasn't pleasant. It's just I think it was moving too much.
So we'll do a turning, somewhat low level. So practice engine failure. Rotors in the line.
This is that rotor thing you were saying.
Yeah,
the rotor thing.
See him controlling the rotor there to keep it in the green?
Yeah.
I'm trying to keep my airspeed up, though. I kind of let it decay. There it is.
Oh, that's spicy.
Feet.
That's spicy.
Check pause, level. Cushion. Landed it. That was good. That was actually a really good turn.
That was like, I'm impressed. Turn there.
There we go. Okay, now we're flying. That was better, no hover. I'll do another low-level auto. Again, I'm not quite sure. It's the last little strokes of the how much pitch I got to put in to sort of arrest my forward speed. That's the tricky part for me.
So I'm going to ask one question. As a person, if you just got in this and started flying, it's that classic thing if you're on your motorcycle course, and the guys always said, who here already owns a motorcycle?
Yeah.
And those are the guys that they're going to have the most difficulty learning because they already have bad habits. Do you think that this, like hundreds of hours of flight time in something like this, would translate to
I think so. I think it would be very helpful from a procedural point of view. Teaching, there's a bit of a panicky moment as you're learning auto rotations that it kind of freaks you out. And I think if you could sort of remove some of that fear in here, procedurally what to do. So practice engine failure. Where's the line? Ball, flare.
Yeah, see, you're flaring. You flare a lot more than I am ever. Yeah,
no, I didn't. Yeah, that sort of translated.
So that clunky. So there goes your rotor.
So every helicopter has a certain amount of inertia in the rotor, and there are some that have high inertia rotors where you can have an engine failure. You can do a full pedal turn and then land before you're in trouble.
Before you run out. So this is a Huey. So it only doesn't it have two? It only has.
It should only be a 2-rotor system.
Right. So then I guess mass doesn't. The number of blades doesn't equal mass because it could be carbon fiber or it could be steel.
No, like a Huey has a high inertia rotor, because they're heavy with weights in the tips, and it's just 2 of them, and so you have more inertia. It'll take longer for that rotor to decay.
Okay.
The Griffin has 4 rotors, they're lighter, and it's a much more rapid decay. So you got to really keep your eye on it, on that rotor. In the Griffin, it'll move more rapidly, like it'll spool or decay.
I saw how custom the case for the rotor when they're being transported.
Oh yeah.
The sled or whatever you call it. I'm like, why does it have to be so complicated? The dude was like, these things are priceless. They're carbon fiber. They're tuned. Like they're super.
It's like balancing your tires, right?
Yeah, they're like the Mona Lisa. We take this very seriously. I'm like, well, it's
the
good.
Chinook rotor blades are handmade.
Wow.
In Philly, I've been in the facility, and they're like.
And they must be obviously large. They're huge, right?
They're 60 foot rotor span.
Wow.
With the whole rotor system, and they are about 250,000 a copy, something like that. Okay, so low level, Auto practice engine failure. So trying to be a bit more smooth. Rotors in a line.
So one thing I'm noticing is the level of proficiency that you're able to speak of what you're doing while doing it.
Did that actually work?
That was cool.
Wait, did I break it?
Yeah, I think, yeah.
Oh, I thought that was
It's okay, no,
good.
but like the fact that you're not getting fire. Like this game likes to make you know that you suck by throwing a fireball at you.
The key is, as you get that nose up in their auto rotation, is looking out your window and using that as your gauge of your forward closure.
Yeah.
That's what seems to work. I know I'm doing only your auto rotations, but it's really fun.
No, this is like a playground for you, right?
This is amazing. So try to do a confined area, maybe inside of that city. Like find a little confined field to land in. I think we saw some out there. Have you tried landing on any of the rooftops or anything?
I haven't tried, not on purpose.
Yeah, not on purpose.
To say that I tried to do it, I don't know. Why don't we? I guess we could. So, like, remember I told you earlier on is I can land, but I can't. I need to do what I need to learn how to do what you did, which is cancel forward momentum without kind of skidding to a stop.
Yeah, it's tricky though, Brian. It's much harder in the simulator than it is in real life.
Yeah.
Yeah, like if you're able to do it in here, I think you'll have no problem in a real helicopter.
Well, let's pray that I never get an opportunity to test that out.
All right, so there's a roof of a building straight ahead, 12 o'clock there, that little office building.
So this game gives you about 5 feet wiggle factor for trees. You can clip through trees, but the bushy part, not the stick part. The collision.
There's a rate issue here. All right, I think I recovered that. We'll see.
So is that you manipulating throttle?
No, it's just the rotor decaying because I asked for power faster than the fuel could get into the engine there.
I get it.
And it's these are massively.
So again, this comes back to the same question. Do you feel that, like, this is an older helicopter than the Griffin? The Griffin has newer, more powerful engines. Would you say that that's?
Yeah, you'd have this is single engine single Huey.
I believe so.
So yeah, a Griffin would have a twin pack, 2 engines.
And that goes through a transmission and a gearbox and a bunch of other.
Yeah, this is tricky though because no references as soon as it goes under the nose.
Yeah, so this is where the VR would be very helpful.
Yeah, 100%. I think VR here would be really neat. I'll try this little confine off to my 1 o'clock here.
So I promise you, the next time you come visit, I'll have this set up VR and we can make an estimate. We'll try not to make anyone sick. I find it's funny, like some people build up a tolerance. It's kind of like smoking. You build up a tolerance to VR.
Oh, yeah.
You get used to it. You kind of fight through it.
Oh, that's the fire you were talking about.
Yeah, it just loves to make you.
I must have hit that power line or something.
Loves to make you just feel like an ass.
That's tricky, man. I do find it in the hover very sensitive in the cyclic.
Yeah.
More in pitch than any other axis. That's probably just a tuning thing, eh?
I can still tune. So you're saying that there's still.
Well, it's still quite pitchy.
Okay. Do you want me to try to numb it?
No, I don't know. I think I'm good because I've gotten every time we change it, it takes a little while to get used to.
Right.
So it's what I do find though is it's the hover attitude that I've got. See, I'm drifting back because I feel like the hover attitude I would need to hover is too nose low. Right? And so that's why I'm drifting back. Because I'm like, no, that's not right. That's way too nose low. I'm going to accelerate forward. But I'll just maybe recage.
So as far as the actual controls, is there nothing is bound right now on any of the things? Can you give me an idea of what kinds of things would be on your hand? Like you were saying, you could like release a slung load. Obviously, that would be a button. But are there trims? Are there like?
Yeah, so you have a force. So most helicopters will have a force trim, like a magnetic brake.
Yep.
And so you'll find a happy place. So for example, in the Griffin, you would be pushing my left thumb here. Or excuse me, my right thumb would be pushing the magnetic brake every time I was going to move the helicopter around. And then when I found my happy place, I could let go of it and just sort of push against the springs a little bit.
Okay.
And just to do fine tuning in the hover using that. So that would be my left thumb. There's a trigger. The trigger would typically be the radio.
Yep.
But most helicopters have evolved beyond that, and they have voice vox systems. So you can just pick up your voice. In the Chinook, the D model Chinook, if you half-click the trigger, you would get intercom. If you full-click the trigger, you got whatever active radio. Every time you talked on the intercom, you had to half-click the trigger.
Okay.
And it was weird, like even with the engines off, doing a debrief with my crew afterwards, I would half-click the trigger every time I spoke to them.
You can't even get up.
Yeah.
You got to stay.
All right, well, let's try flying again here. This would be, like in the Griffin, there's an attitude mode, which is a little bit of automation that allows you to set an attitude and it'll stay there.
Okay.
And so this little hat here, you would be able to sort of fine-tune that to set that attitude. And you could almost take your hand off. It'll just hold that distance above the horizon pretty much of the attitude that you set. In this vintage helicopter, you wouldn't have that.
Right.
That's an automatic flight control system, and it has little servos and everything that do that. On the Collective, some Collectives have a forced trim, so a magnetic brake as well. The Griffin does not. There's typically lights, so to extend and reduce or retract lights, both visual and infrared searchlights.
Okay.
And then there's the engine trims here. So I'm not sure if it actually works. I'm just going to look.
No, so none of those are bound.
Okay.
This is why we're doing a fact finding, because what I'm going to do is rewatch the video, listen to what you said, and then go on a witch hunt in the menu looking for those things.
Yeah, so the engine RPM, you'll be able to increase it or decrease it here. And in multi-engine helicopters, you can balance the engines out to make sure that they're both producing the same amount. So you'll have sometimes a switch you'll have two switches or a switch that toggles between the two engines for that. Searchlights on and off. A hook release, typically it'll be a guarded switch that you have to flip up and push. And there's sometimes a pedal, like in the Griffin, there's a mechanical release pedal you can push. A lot of aircraft that have heads-up displays, somewhere you would have a control that would toggle through pages.
Okay. And
you could declutter. On the Griffin, I think there's like 4 pages, and there's a declutter page that just removes it all. If you're just overloaded, you don't want more information in front of you.
So a lot of the stuff that you're speaking about is on the startup panel on your right. So that's where you have your engine control, a startup button, APU, and then there's that mode switch that takes you through different flight characteristics, HMD, which is your head-mounted display. And then you got laser and a bunch of other stuff that I'm a weekend warrior when it comes to it.
So an APU is, you would have that in a helicopter like a Chinook, where it's an auxiliary power unit. It's a small jet engine. And it's the first thing you start. It actually gives you electrical and hydraulic power. And it actually, in the Chinook, it'll allow you to start the engines using hydraulic starters. And so it does allow you to power up the hydraulic system, get the electronics, all the avionics on before the rotors start turning. And then typically once the engines are started, you would turn the APU off.
So that would be like if you're starting up a 767 on the runway, you see that large generator kick in, and that's
the APU. It's a small jet engine that essentially gives you electrical and hydraulic power. And the interesting thing is, if you take your hands off this thing, look how stable it is. It's amazing.
So there's some tanks also have an APU, like the Leopard, the Abrams is a gas turbine engine, like a helicopter. So while it's idling, it's horrible on fuel. So if the tank is going to be there for an hour, they would shut the gas turbine off and they would turn the APU on to keep the hydraulics for the turret and the radios and everything functional.
So the Griffin and the Huey, they did not have APUs. I believe the Blackhawk has an APU. The Chinook has an APU. Apache's got an APU. Very, very useful if you need to be on a readiness condition, like a 5-minute notice to move.
Right.
You can have everything powered up, all of your avionics on, everything loaded, even weapons up in an attack helicopter context. And then just conduct a start and go, and that actually allows you to be very ready for things like medevac missions or whatever. So APUs are really, really useful in helicopters.
Yeah, of course, timing that scenario is super critical.
The downfall on the Chinook is that the APU has no fire protection on it. You have a fire light, but there's no extinguisher on it. So if it catches fire, there's no way to put it out.
Does it take the whole chopper with it?
Yeah, it's in the tail. So the big issue on the Chinook is that you don't operate the APU in flight unless there's an emergency.
Right.
If you get a total electrical failure, you start losing all the stability augmentation on the aircraft, and it can be quite spicy to control it. Mm-hmm. And so having the APU be able to come on and provide the electrical power that you were getting from engine-driven generators. So you had a dual engine failure in the Chinook, and your rotor decayed below 88%. You lost all electrical power in the cockpit, and the only way to get it back would be get your rotor back, but also you could get your APU on.
Again, you're not catching on fire.
Well, still the rotor departed the fix there. Is there anything else you wanted to do here, buddy? Or
No, like I was just what you've done tonight so far has exceeded my expectations. Obviously, thanks for the interview part in the beginning. Super nice.
no?
Don't worry, I won't make you go through that again. Next time we come over, it'll be. Do you remember Chris? He was over last time. If you don't remember, go watch the other video.
Sure, man.
But yeah, so my goal is obviously to get the 6DOF set up and then see how, like, I'm super curious as to how much more feedback you get as a pilot or as an occupant if that extra range of motion gives you better feedback, and of course also the speed of it and its capability to move in directions that this one can't. To me, is
It's very realistic though in terms of the bank rates and stuff that you get, and the other than pitch, most of the control inputs I think are very, very accurate.
so the thing I like about rotor instead of air, like, so Cessnas is not. We're not talking about Cessnas. Most aircraft that people want to fly can go upside down, and that means that in something like this, if you're in an F-14 and you invert, what's the sim system supposed to do, right? So it's not terribly realistic. But choppers historically don't invert, and some smaller aircraft don't invert, and of course commercial. I don't understand the draw for flying big honking commercial jets, but I'm not a pilot. Like, I'm not a real pilot, and I'm not trying to learn how to be a pilot. So maybe
some people like.
I'm just not in there. But I know of guys that like do an 8-hour flight. Like
Oh yeah, do
Montreal to Miami. You know, taxiing, pushing all the buttons, and talking to traffic, and they're like, I'm just like, fantastic. But you know, go get the diapers.
This is awesome, man.
So this is what I do. I get spicy and I do stuff that civilians would be taking pictures. Like, why is that chopper flying over my apartment?
It's pretty good though. It actually is pretty good in terms of its sensitivity and stuff. I just love to land on one of these roofs. There's not enough hover references to do it.
Well, this is what I'm saying. Come back and we'll get VR configured.
This is awesome. This is really good. I think I'm breaking my half rotor rule here.
Probably, but that's okay. I turned this into pod racing. I'm sure the FAA would be finding me. Some of the stuff I do.
Some poles and wires.
I just think you get the sensation or the sense of speed is obviously more fun when you're lower because.
Oh, I really wanted to get under that bridge. All right.
I don't know if the game will let you. Like, okay. I don't know if it's modeled properly. I know more modern games they bother, but I think the game developers are probably those guys that are like, oh, don't worry, he'll be at 1,000 feet flying like a normal person, and no one wants to do that, or I don't know. Nobody has sat in there and not tried to do this. This is the thing that everyone wants to do. Like, fly 10 feet over a road that has truck traffic.
Yeah, it's pretty cool though. The entities are all moving around. So we can get over this guy's roof.
So with the more modern UH-60, you also get new maps and you get a refresh. So the actual download for UH-60 is like $70, and I'm thinking that that's necessary. I need to try it. But I was concerned that I would get lazy, like that the chopper would perform so well that I wouldn't respect, you know? Because I go back and fly the Mi-8. Oh, this is, what are you doing? No, this is not going to work. So, oh my God.
So good. So good, Brian.
You're hired.
Oh, this is amazing. I feel like TC.
You're the only person I know who would successfully do that.
The control touch of this thing is really good, though. You get used to it. And this is a lot like tack flying.
So the purist that does DCS, the ones that do the missions and push the buttons and everything, I will get there eventually, but I am addicted to what you're doing. Just bombing. Yeah, no.
Oh, man, there's always a flaming crash at the end.
And the tree.
Yeah.
And the tree.
This video is crazy. This is likely the longest video that I ever produced, and Chris did all of the heavy lifting. It's such a pleasure to be able to bounce questions off and get his years of experience as an answer. I hope you enjoyed what I feel is a truly special opportunity, and my goal is to invite Chris over as many times as he's willing to test out the more elaborate motion systems, adding virtual reality, and perhaps testing more complex missions once I have all of the bindings and controls dialed in. I'd appreciate you taking this small effort to share this not only in the sim forums, but also on pilot forums, because we all share the same question. Is sim at the point where it's good enough? Can you learn without a $1 million simulator? Can we have that capability in our house? Thank you very much for spending your time with me. I had so much fun with this video. Subscribe so you don't miss future videos. Fly safe.